Hi guys, my name is Rene Francolini and I'm going to be talking about our evaluating the effect on marine biodiversity of marine protected areas, which are MPAs, worldwide. And this was the presentation on the Ocean Biodiversity Information System, OBIS, MPA project. And these are the wonderful group members I have the honor to work with this week. So just an overview of what our goals were for this was we wanted to create something where the user could input a specific marine protected area of interest, a time period that they're interested in learning about, and a specific taxa, and an environmental metric. So sea surface temperature, bathymetry, chlorophyll A, whatever that might be as well. And here's a map of various marine protected areas. So for instance, if you input this information and you want to know more about this marine protected area, we can then calculate the biodiversity ES50 metric for you. We could compare the OBIS database abiotic environmental factor data with other satellite data for that area. We can graph specific taxa and their associated abiotic factors, which is your environmental metric of interest. And we can also compare what is in that MPA versus around that MPA. So you can see if the MPAs are functioning the way that we are hoping that they would. And so as I talk, OBIS is this open access database. MPAs are your conserved waters that are conserved for various reasons. And then your standardized species diversity is the ES50, which is the expected number of distinct species in a random sample of 50 observations. And so it's a good indicator of marine biodiversity richness. So I'm just going to walk through this Jupyter notebook here. The first thing would be, we worked on a program to download MPA polygons from NOAA. And I'm not going to go into it, but we have these two various other scripts that work on getting all the MPA polygon dimensions and geometry from NOAA. So we have one file and two files, and I'm not going into this as much because we're not using it and running it in this presentation, but it exists. And so what you can do is you can choose your polygon of interest. So OBIS requires a specific text formatted geometry input. So this is just a function to change your input to be aligned with OBIS's requirements. We are currently loading the California. We're going to look at SoCal Canyon and Point Lobos as examples here. So this is taking in the shape files and converting it to be a polygon string that's usable with OBIS. And just for reference, this is what we're looking at, SoCal Canyon and Point Lobos. And so now that we have that geometry, we could insert it here and grab all the occurrences within OBIS. So here we have over 6,000 within SoCal Canyon and 1,600 within Point Lobos. We're going to take a quick look here. You see that they have, one has 148 columns of information. One has 137, so there's different amounts of information and obviously different records. We're now going to compute the ES50, and then that's going to be done. We're just doing individual counts within each of the MPAs and aggregating those species counts. So you see here, one of them has 225 species. There's some of them, one of them has 69 species. And then it calculates the ES50 value, which for here, it's 2.87. For here, it's 12.2. We are working on these calculations. These seem to have a pretty low value compared to what might be expected, but to be determined, we are learning. And then you can go and look at specific taxa and not just the overall MPA. So you have your function to learn about the environmental metric of interest, which is your SST here. And it tells you that your range is between 12.73 and 12.78, which is not much, but that's okay. And right now we're just focusing on your rockfish at the SoCal Canyon. And so now we can visualize this. This is just going to output a histogram. So this is for every sighting of Sebastes in OBISCS and the associated SSTs. And obviously there's not much range of the SSTs associated with these sightings. And then you can also map your taxa sightings with their associated environmental factor. And we put this on the map. So this is within the boundary box of that MPA of interest. And the gradient is being associated with whatever your environmental metric of interest is. So that's what we've done, hoping to move forward into a world where we can also get some of this other information and easily compare outside of the MPA, within the MPA, as well as the OBISC database versus other satellite data as well.